converting units is an important skill because a lot of times units are not given in units that you need or units that make sense to you. So here this person is going about 42.5 meters per second, and I can imagine what 42.5 meters per second is and how far and what time that represents. But I just don't have a good feel for that measurement in everyday life. So I'd like to get that into miles per hour. And I do, so we got to do two things. We got to get meters converted into miles and seconds converted into hours. And I do want to acknowledge that Google exists. Okay, so yes, you could take 42.5 and plug that number into that box right there, and this number will pop out of that box right there. You're just searching in Google. There are limitations to that. For example, back with the significant figures, this had 3 sig figs, and the answer it gave was well more than 3 sig figs. It should have been just 95.1 miles per hour. The other limitation to this is when you put something into a box and you get out something else, that's pretty close to magic. And magic is simply a lack of understanding. And a lack of understanding leads to mistakes. And yes, Google is a fantastic tool, but it doesn't replace understanding. So let's get the understanding first. We're going to practice a really neat technique of converting units. And once you have a good understanding of that technique, then maybe you can just go to Google because you have the understanding that you need. Talking about mistakes, in the medical field, heparin is a drug that's often used as a blood thinner, and it will dissolve blood clots. And it's a very dangerous drug because it thins your blood. If you get too much of it, you'll die. And if you get too little of it, you might die from the blood clots that it was trying to fix. So a doctor would order a certain regimen of heparin. So either it's low, medium, or high. That'd be how aggressive you want to go for this. It is based upon the patient mass. And a bolus here would just be simply giving a very large dose up front and then tapering to a more smaller dose. But in this case, we're not going to give that large dose right up front. But what we would like to calculate is we're going to hang our IV bag, and then we're going to program the IV pump to provide a certain number of milliliters per hour. And truly, if you get this wrong, you can kill your patient. So we're going to take some numbers here, and we're going to divide those numbers, we're going to multiply those numbers, and you have to decide, do you multiply or do you divide? We're going to let the units tell us what we need to do. Okay, so here's the doctor's orders. We're going to do a medium regimen, no bolus, but the initial infusion rate is going to be 15 units of heparin per kilogram for the person per hour. And we want to make sure we don't go past a maximum of 1,400 units per hour. Okay, so I need to get, whatever I need to do with these numbers that are shown here, I need to get milliliters in the numerator and hours in the denominator. And I just got to manipulate these numbers, so that's what happens. Well, I'm going to go ahead and start with this one because it already has hours in the denominator. If I multiply that number by the 80 kilograms, the mass of the person, I have kilograms on the bottom here and kilograms on the top up there. So I've just gotten rid of kilograms. And if I just multiply those two numbers, I would get 1,200 units per hour. And then I just make sure I check to make sure that that result there wasn't greater than that result. If it was bigger, then I would just go with the 1,400. All right, so now we have this 1,200 units per hour. And I remember I'm still trying to get it into milliliters per hour. Well, I see this box here, and it says that this has a concentration of 100 units of heparin per milliliter. So 100 units per milliliter is the same thing as 1 milliliter per 100 units. Okay, so either this is equal to this or this is equal to that, same thing. But I flipped my fraction here because I had units in the numerator there, units in the denominator there. They're going to cancel, and my unit is just left over as milliliters per hour. And so 12 milliliters per hour is what you want to set the IV pump at. Now, if you just plug numbers into a box, you might you probably would get the right answer, but you're likely to make mistakes. One mistake that has happened in the past is where the doctor orders it for an 80, for just 80, not specifying that it was kilograms. The one example I'm thinking of, it was for an old, very small person, and they weighed 80 pounds, not 80 kilograms. And it wasn't clear, was it pounds or kilograms, but the doctor meant pounds, and the pharmacist and the nurse assumed it was in kilograms. And because there's 2.2 pounds per kilogram, they ended up getting twice as much heparin as what was necessary. They killed their patient. Okay, very important to do this correctly and look at the units. Maybe a not so life and death example here, but let's say that you want to do a road trip from Denver to Fairbanks, Alaska, 3,066 miles. And we want to calculate, before we do the trip, how much it's going to cost in gas. So I want to take these numbers here, my miles per gallon, the dollars per gallon, and the number of miles, and come up with an answer in dollars. Well, you're going to take these three things, you're going to multiply, you might multiply two of them, you might divide the other one, but maybe you could wander through this and figure it out. But the units tell you what you need to do. So I need to get my final unit into just dollars. I'm going to start out with this one here, this $4.269 per gallon, or I'm putting the dollar sign after the number because I'm kind of treating it as a unit, as it really is. But I got dollars in the numerator here. And then I got to multiply by something to get rid of the gallons. I don't want gallons in my final answer. I just want dollars. So I'm taking my mileage here. I'm going 27.1 miles per gallon of gas. Well, if 27.1 miles is the same thing as a gallon of gas, then a gallon of gas is the same thing as 27.1 miles. I flipped my fraction here. The reason I did that is because gallons is in the denominator and gallons is in the numerator. They cancel. If I stop right there, my answer would be in dollars per mile if I just divided those two numbers. So now I'm going to take this number here, the 3,066 miles, and I have miles in the numerator up here. I put it over 1 just to emphasize that it's in the numerator. And then miles in the denominator, miles in the numerator cancel, and my unit now is just dollars. So I take this and I multiply it by that, and I divide by that. I'm not going to bother multiplying by 1 or dividing by 1, but when I plug those numbers into my calculator, this is what the answer gives us on the calculator, because our calculator doesn't understand that these are measured numbers. So let's go ahead and get a little bit more practice with significant figures. There are our weakest link here. There's these three numbers here, which is our weakest link. This has 4 sig figs. This has 4 sig figs. This one only has 3 sig figs. So that's our weakest link. We need to round our answer to just 3 sig figs. So I'm going to, because this number is greater than 5, I'm going to round the 2 up to 3. And we have to understand that these numbers here can vary throughout the trip. Going up over a mountain pass, if there are a lot of mountain passes, that might change your average. And the cost would not be the same all the way through the trip as well. So it's a good estimate. All right, now let's look at some of the rules about doing unit analysis, or what I'm calling dimensional analysis. You've done algebra, and you can cancel something if it's in the numerator and the denominator. So the x's cancel here, the y's cancel, and I'm left with just z. Okay, so I take that, times and I still have z there. But the cool thing is you can treat units the exact same way that you treat variables. If I've got 3 days and then 24 hours per 1 day and then 60 minutes per 1 hour, days on top, days on bottom cancel, hours on top, hours on bottom cancel, and I've just this times this times this. All my units have canceled out except minutes, so it's just this many minutes. So you can treat your variables the same way you treat your units. That x times x is x squared, meters times meters is square meters, or seconds times seconds is the same thing as seconds squared. You can treat your units the exact same way you treat your variables. All right, here's an easy example. 75 divided by 75 is 1. 256 divided by 256 is 1. 0.19 divided by 0.19 is 1, and pi divided by pi equals 1. Maybe just one example would have been enough there. The point is, if you have the same number in the numerator as you do the denominator, the resulting fraction is equal to the number 1. Okay, we'll hold on to that idea for a moment. Okay, another easy example. If we take a number and we multiply by 1, we get that same number. Okay, so number times 1, same number, same number, same number. All right, sometimes, or in this example here, it was easy to see that the numerator and the denominator were the same, so that fraction is equal to 1. But this fraction is also equal to the number 1, because 2.54 centimeters is the same thing as 1 inch. So when the numerator is the same thing as the denominator, that fraction is equal to 1. So if I had 10 inches and I multiplied by 1, I get 10 inches. But if I take 10 inches and I multiply by the number 1, I get 10 inches. So 25.4 centimeters is the same thing as 10 inches. And the cool thing here is this, I would call this a fancy one, where it doesn't quite look like the numerator and the denominator are the same, but they are. So inches on top and inches on the bottom cancel, and I would get centimeters. And you can easily make a fancy one. All you have to do is take any conversion that you know, or a conversion that you can look up, and if they are equal, put one in the numerator, the other in the denominator, and that fraction is equal to 1. And the reciprocal of that fraction would also equal 1. So if 2.54 centimeters is the same thing as 1 inch, then 1 inch is the same thing as 2.54 centimeters. And just some familiar ones: 1,000 milliliters per liter, 60 minutes in an hour, 2.2 pounds per kilogram, 1.609 kilometers per mile. Maybe these are ones you're familiar with. If not, you're going to become very familiar with them. But they're all equal to 1. So here we go. Now we're ready to convert using this really neat technique called dimensional analysis or unit analysis. The question is, how many kilograms is 6,850 inches? So what we got to do is we may not know a direct conversion from inches to kilograms, but if you can envision a connective path going from inches to kilometers, not kilograms. So inches, I can turn into feet, because I know there's 12 inches in a foot. I can turn feet into miles. There's 5,280 feet in a mile. And then I can convert miles into kilometers. There's 1.609 kilometers in a mile. So here's what we're starting with: 6,850 inches. I'm putting that over the number 1 just so I can clearly mark my fractions. And I really do prefer that you mark your fractions with a horizontal line versus a big slash here, a big diagonal slash, because this really clarifies which is in the numerator and which is in the denominator. So I'm going to take that number and I'm going to multiply by the number 1. Well, 12 inches is the same thing as 1 foot, so that fraction equals 1. Inches on top cancel with inches on the bottom. And when I take that number and I divide by 12, how many inches do I have? Well, I've got that many inches. But if I divide by 12, it would also be an equivalent number of feet. Okay. Now I'm also going to multiply by another number 1. That 1 mile is the same thing as 5280 feet. Feet on top, feet on bottom, cancel. And then I'm going to multiply by 1 more time. 1.609 kilometers, same thing as 1 mile. So miles on top and miles on bottom, cancel. My unit, all the units have canceled out except kilometers. So I just need to take that. I'm not going to multiply by 1, that's no fun. But then I'm going to multiply by this, and then I'm going to divide by this and that. So let's talk a little bit about order of operation. When you type numbers into the calculator, are you telling the calculator what you think you're telling the calculator? So if I were to take this times this divided by this times that, so this times that divided by this times that, is it going to give me the right answer? And no, because when you type it in this way, you thought you were telling it this, but you were actually saying take those numbers, divide by 12, and then multiply by 5280. So that is not the right way to do it. So students say, well, I'll use parentheses. And absolutely, parentheses work. I could take this times this divided by open parentheses, 12 times 5280, close parentheses. But that adds 2 more buttons you have to touch. It might actually add 4 more if you had to hit second and then the parentheses. So that works, but there's a better way to do it. All I got to do is take that times that, divide by 12, and divide by 5280. So that times that divided by this and divided by that. When we do that, this is the answer our calculator gives. Doesn't understand that these numbers, some of them were measured. So let's talk about sig figs here. You know, if we put down that answer, we're being dishonest. So how many sig figs are in this number? Well, the 0 is just a placeholder, so it's just 3 sig figs. And this number has 4 sig figs. How many does this number have? It's not 2. This is that tricky one. It looks like there's 2 sig figs in this number here, but that was an exact conversion. 1 foot was exactly 12 inches. So that actually has an infinite number of sig figs. And the 5280, it looks like it has 3 sig figs, but it is also an exact conversion. 1 mile is exactly 5280 feet. So my limiting factor here is 3 sig figs. Our answer has to have 3 sig figs. Because this number was greater than 5, we round the 3 up to a 4. All right, let's do that same problem again, but just take a different route. You know, if the route that you take is correct, you should get the correct answer. And there's multiple ways to that. So maybe this time I could have gone from inches into centimeters, centimeters into meters, and then meters into kilometers. So the middle portion of this was a different route. Okay, so inches into centimeters, there's 2.54 centimeters per inch. Inches cancel. And then centimeters into meters, there's 100 centimeters is the same thing as a meter. That's a fancy 1. Centimeters cancel. And then I got to get meters into kilometers. There's 1,000 meters in 1 kilometer. So meters cancel. So I just have to take this times that, divide by this, divide by this. This time my calculator says this. And notice it's a different answer than we got over here. Okay, but when we apply sig figs, this has 3 sig figs. That looks like it has 3 sig figs. And before forget what number, 68, 67, somewhere in there, that only was 3 sig figs, but the inch was redefined to be exactly 2.54 centimeters. Okay, that's an exact conversion. There's exactly 100 centimeters in a meter, and that's an exact conversion. Those are exactly the same. So 3 sig figs is my limiting factor there, and so we get the same number. We get the same answer when we round to the correct location, no matter which way we do it here. Now back to this problem, we used Google to do it at first, but let's see how we would go ahead and do the details here. I got to get meters into miles, and I got to get seconds into hours. So let's start with this. This is what we're going to start with, and we got to do two things. We're going to get meters into miles by going meters into kilometers, and then kilometers into miles. We got to get seconds into hours, and we're going to do that by getting seconds into minutes, and then minutes into hours. So here's what we're starting with, the 42.5 meters per second. That's a fancy one. Meters on top, meters on bottom cancel. This is a fancy one. 1 mile is the same thing as 1.609 kilometers. Kilometers on top, kilometers on bottom, cancel. Now a lot of students want to stop, write down their answer, and then start a new problem. We don't need to. We got to get seconds into hours here, because I did get my answer. I did get meters into miles, because here miles is right there, meters canceled. But I don't have to do a new problem. I got to get seconds into hours. I got to multiply by a fancy one right here that has seconds in the numerator. Even though seconds are way over here in the denominator, they'll still cancel with seconds in the numerator over there. So you didn't have to start a new problem, just continue the same problem. So if I stopped right now, my answer would be miles per minute. But I want to get into miles per hour, so 60 minutes, same thing as 1 hour. Minutes on bottom, minutes on top cancel. My unit becomes miles per hour. So if I take that, times that, times that, divide by this, divide by that, this is what my calculator says. But let's look at sig figs. 3 sig figs here, an infinite here, an infinite here, an infinite number of sig figs there. Those were all exact conversions. That's not an exact conversion. Okay, there's more decimals that were not being shown there for the miles to kilometers. So my limiting factor here, my weakest link, is 3 sig figs. I'm going to round to 3 sig figs, 95.1 kilometers. All right. One other thing we have to be careful of is when we're dealing with squares and cubes of units. Like 1 yard is the same thing as 3 feet. Okay, so you could make a fancy one. 1 yard divided by 3 feet is 1, or 3 feet divided by 1 yard is also 1. Okay, but when we're doing square yards, like an area, this is 1 yard by 1 yard. So that's actually, there's not 3 of these in one of those. There's actually 9 square feet in 1 square yard. So if 1 yard equals 3 feet, 1 square yard equals 3 squared square feet. We have to square the conversion as well. This was 1 yard by 1 yard, which was the same thing as 3 feet by 3 feet, so 9 square feet. And then here's a cubic yard and a cubic foot. There's not 3 of these that fit into there. Not 9 of them that fit into there, but we count them all up like this, and we get 27 of those cubic feet. 27 cubic feet would be the same thing as 1 cubic yard, because 1 yard by 1 yard by 1 yard is the same thing as 3 feet by 3 feet by 3 feet. So if 1 yard equals 3 feet, 1 square yard equals 3 squared square feet, or 1 cubic yard equals 3 cubed cubic feet. If we cube the unit, we also have to cube the conversion. So now this is an imperial unit, this is a metric unit, and we're trying to figure out how many of these little guys will fit into that big guy. So this is 1 inch by 1 inch by 1 inch. This is 1 centimeter by 1 centimeter by 1 centimeter. Okay, but if 1 inch equals 2.54 centimeters, we have to cube this and cube that, so that, and when you're cubing that, you're cubing everything inside the parentheses. So the 1 gets cubed, you still have 1. The inches get cubed, but this gets cubed and that gets cubed. So we get 2.54 cubed. 16.4 cubic centimeters is the same thing as 1 cubic inch. All right. These are the Rhine Falls on the border between Switzerland and Germany, and this is the Niagara Falls, which is on the border between the USA and Canada. And metric units for the flow of that would be 650 cubic meters per second, and this would be about 50,000 cubic feet per second. Well, that's a bigger number, but it's a smaller unit. Which one has more water flowing every second over it? So let's convert this one into cubic feet per second. Get them into the same units so we can actually compare. 650 cubic meters per second. We're going to get into cubic feet per second. 100 centimeters, same thing as a meter. 1 inch, same thing as 2.54 centimeters. 1 foot, same thing as 12 inches. Okay. Now, if I were to try to cancel units, I've got a meters in the denominator and a meters cubed. They would only cancel to give me meters squared. So that's not the right way. We have to cube each conversion. So all of that gets cubed, all of that gets cubed, and when all of that gets cubed, everything inside of that gets cubed. That gets cubed, that gets cubed, and that gets cubed. Okay, so cubic meters would cancel. This one was cubed, 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 and cubed. So cubic centimeters and cubic centimeters cancel. And then this one was cubed, 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 and cubed. Cubic inches and cubic inches cancel. My unit becomes cubic feet per second. So I just have to take that times 100 cubed. I'm not going to bother with this one or that one. It's still just multiplying by 1. But then I'm going to divide by 2.54 cubed, and I'm going to divide by 12 cubed. When I do that, my answer on my calculator says, I think that's just the same thing. My answer on my calculator says all of those numbers there, but with sig figs, 2 sig figs here, infinite, infinite, and infinite. So I just have to have 2 sig figs in my answer. I'm going to round up and call that 23,000 cubic feet per second. So on average, this runs about half the flow of Niagara Falls. There are 2 ways to convert from one unit to another. One way is the way that I just taught you, and the other way is the wrong way. Okay? Make sure that you're practicing this technique. You can't go wrong. Nobody's going to die because you did the answers correctly. All right, dimensional analysis.